Hi, so for today we're going to talk about again polar form of a complex number part 2. This is still a part of our advanced engineering mathematics playlist lecture. So first let me just recall, okay, if you haven't watched the part 1 of this video, please watch it first before proceeding with this video. So if you are new to my channel, please don't forget to subscribe to my channel, okay, and for more math and engineering tutorials. So we can express polar form into this complex number r cosine theta plus r I sine theta, where r is equivalent to the square root of x squared plus y squared, and theta is the arctan of y over x, and we have a note. Okay, so if the polar or if the rectangular coordinates is located at quadrant 2, we simply add pi. If you're using the calculator, we have for quadrant 3, it is simply we will subtract pi. Again, if it is located in quadrant 3, we simply subtract pi from it. So let's try to solve some problem again on how we are going to solve or convert rectangular form into polar form. So let's have this problem number 1. So in this problem, we cannot simply apply easily the formula. We have first to reduce this or to simplify this complex number so that we can apply this formula. So we must simplify this complex number. Again, it has a denominator. Our goal is to multiply it by the conjugate of the denominator. So we have 2 squared root of 2 plus 2 squared root of 2i over 2 squared root of 2 plus 2 squared root of 2i. So what will happen here is that we have negative 2 squared root of 2 minus 2 squared root of 2i, okay, over, so this is difference. So we have 2 times 2, that should be 4. Square root of 2 times square root of 2, that should be 2. Okay, negative times positive, that would be minus. We have 2 times 2, that's 4. Square root of 2 times square root of 2 is 2. And I times I is I squared, which is, again, I squared is equal to negative 1. So we have an answer, negative square root of 2 minus 2 square root of 2i over 8. Okay, and this would be negative times negative would be positive, so 8 plus 8. Okay, so we have negative 2 square root of 2 minus 2 square root of 2i all over 16. And we can simplify this. We can simplify this as negative 2 square root of 2 over 16 minus 2 square root of 2i over 16. And we know that this can be cancelled, so we have 8 here. Okay. So what will happen here, we simplify this as negative square root of 2 over 8 minus, okay, square root of 2i over 8. So, and now we can actually convert this into polar form because it is actually in a simplified form. So we can get r as negative square root of 2 over 8 squared, okay, plus negative square root of 2 over 8 squared. That's a square root, okay, here. So our answer is 1/4 if you're going to calculate it. So our angle arctan is simply equal to 1 because these are the same. So we have negative square root of 2 over 8 of divided by negative square root of 2 over 8. That is simply equal to arctan of 1. Okay? Which is equal to 1/4 or pi over 4. Again, take note that this complex number is located at what quadrant? Negative, we have a negative here, and the negative here, that's quadrant 3. Okay? That is in quadrant 3. So what are we going to do here? If it is in quadrant 3, we have to subtract pi from what we get on our calculator. So, what will happen if we subtract pi? That is negative 3 pi over 4. So, it means that the polar form of negative square root of 2 over 8 minus square root of 2i over 8 is now equal to what? To 1/4 cosine of negative 3 pi over 4 plus, okay, plus I sine of, I'm sorry, that should be 1/4 I sine of negative 3 pi over 4. Or we can factor out 1/4 so that it becomes cosine of negative 3 pi over 4 plus I sine of negative 3 pi over 4. So if you evaluate this, this should be equal to this. Okay? So that's how we get the polar form for this problem. Okay, for number 2, let's try to solve this problem. So we have z is equal to negative 2 over 1 minus square root of 3i. Okay, so we need first to simplify this before we can apply our formula. So we can multiply this by the conjugate of the denominator. It's fine. Okay, we should simplify first this. So we have negative 2 minus 2 square root of 3i for our numerator. For our denominator, we have 1. Okay, we have 1 square root of 3 times square root of 3. Okay, that's minus, that's 3. I times I squared, that is equal to negative 1. So we have negative 2 minus 2 square root of 3i over, we have 1 plus 3. Because negative 3 times negative 1 would be positive. So we have negative 2 minus 2 square root of 3i all over 4. We can rewrite this as negative 2 over 4 minus 2 square root of 3i over 4. We can simplify this. Negative 2 over 4, negative 1 half. And this is negative 1 half also. Okay, or negative 1 half. This two would be cancelled. Okay, so we have square root of 3i over 2. Okay, so we have now this form. This is located in quadrant 3. So don't forget that if we get theta, we should subtract pi. So we get the r. R here in this case would be negative 1 half squared plus we have negative square root of 3 over 2 squared. This is square root of 3. Let me just rewrite this. So negative square root of 3 over 2. So if we evaluate this, this is simply equal to 1. Our theta would be arctan of negative y square root of 3 over 2 over negative 1 half, where 2's will cancel. Negative square root of 3 over negative 1, that is simply the arctan of negative or square root of 3. So whatever we get here, make sure that your calculator again is in radian mode. Okay, so we get what? We get pi over 3. And since this is located in quadrant 3, we subtract pi. Our answer for angle is 2 pi over 3. So our answer in converting negative 1 half minus square root of 3 over 2i into polar form is r cosine theta plus I r sine theta. So we have the value of r, which is 1. Our cosine theta is 2 pi over 3 plus 1i sine 2 pi over 3. Or we can neglect putting 1 because it's understood. So this should be our answer. Again, this is located in quadrant 3. So we have to subtract pi. And it is not positive 2 pi over 3, but rather it's negative. It's negative 2 pi over 3. Okay, my mistake. That should be negative. So pi over 3 minus pi is equal to negative 2 pi over 3. Negative 2 pi over 3. So this should be our answer. So for number 3, okay, the complex number is negative 1 over 2 minus 2i. So how do, again, we cannot perform directly the substitution of r and theta here. So we have to reduce this complex number by multiplying by the conjugate of the denominator. So we have this. So it should be negative 2 minus 2i on the numerator. Let me change my pen. It should be color black. So we have negative 2 minus 2i all over. We have 4 minus 4. Okay, it's FOIL. Okay, 4 minus 4 times negative 1, because I squared is negative 1. So we have negative 2 minus 2i all over 4 plus 4. That is negative 2 minus 2i over 8. And we can simplify it by this. Okay, we can rewrite it. So negative 2 over 8 is negative 1/4 minus 1/4 of I. So this is our complex number, our simplified complex number. So again, this is located at quadrant 3 because it is negative for our x and negative for our y. So we have to subtract pi again when we are getting the theta or the argument. So we have to get r. The r of that is negative 1/4 squared plus negative 1 over 4 squared, which in turns out to be square root of 2 over 4. That's our r. For our theta here, theta is arctan. As you can see, that should be equal to 1. Okay? Arctan of simply 1. Okay? And the arctan of 1 is pi over 4. So again, this is what we get in our calculator. This is what the calculator gave us. So we have to what? Subtract it from pi because it's located in the quadrant 3. So we have theta pi over 4 minus pi. Okay, so our answer would be negative 3 over 4 pi. Okay, that's our argument or the theta. So, negative 1/4 minus 1/4 I in polar form, that is r, which is square root of 2 over 4, cosine of negative 3 pi over 4 plus square root of 2 over 4i sine of negative 3 pi over 4. And we can factor out square root of 2 over 4. We have cosine of negative 3 pi over 4 plus I sine of negative 3 pi over 4. So this should be our answer for this problem. Okay, for the next problem, the only way for you to actually get better in advanced engineering mathematics and as well as in any other math subjects is to solve more problems. More problems, more chance of winning. 1 over 1 minus I plus 1 over 1 plus I. So we need to get the polar form of this complex number, given rectangular complex number. So as we all know, we have to eliminate the I in the denominator by multiplying it by the conjugate. Okay, so that's for the first term. And secondly, we have plus 1 over 1 plus I. So the conjugate of it should be, they are not the same denominator, so we cannot easily add them. Okay, so we have to eliminate the I in the denominator. Okay, so the conjugate is 1 minus I for this term. So if you're going to perform it, what will happen is that this would be simply 1 plus I, and this would be 1 minus I squared. I squared is negative 1. Okay, and for the second term, we have 1 minus I. Oh, this is 1 minus I squared is negative 1 also. So we have 1 plus I plus 1 minus I over, this is 2. So we can actually combine them. This is 2, 1 minus negative 1. So as you can see, this would cancel, plus I minus I. Okay, and so we have 1 plus 1 is 2 over 2 Or in other words, we have 1. We simplify it as 1. Okay, and get the polar form of that. So we have 1 squared plus 0 squared. Okay, and that is equal to 1. Our theta would be arctan of y, which is 0 over 1, which is actually, calculator will give us 0 value. Okay, or upon inspection, that would give us 0 value. This 0 is correct. Okay, because in the Argand diagram, that one is located here. So this is the positive x-axis from which we reference or we refer our theta. So it does not have any angle. So it's actually correct that this is 0. Okay, so our answer in getting the polar form of that, okay, therefore, that should be r cosine theta. R cosine theta, which is 0, plus I sine theta, which is 0. So, or in other words, okay, this, if we simplify this, this is simply equal to 1. Okay, sine 0 is 0, cosine of 0 is 1, which is simply equal to our value of 1. So for number 5, let's try to solve some problem. Number 5, we have 2 minus I over I minus 1 minus I over I. As you can see, they have the same denominator. So we can actually rewrite this as 2 minus I. We distribute the negative sign. So we have minus 1 plus I all over I. So as you can see, we have some cancellations here. Negative I plus I. Then we have 2 minus 1. That is 1 over I. So we need to simplify this. Okay, we need first to simplify this by multiplying it by the conjugate of the denominator, negative I. So what will happen here is that we have negative I all over negative I times I is negative I squared. But we know that I squared is negative 1. So we have negative I all over 1. And that is equivalent to negative I. So our simplified form for the rectangular is simply negative I. So if we get the r and theta of this should be 0 squared plus negative 1 squared, which is actually 1. Our theta in here is arctan of negative 1 over 0, which is math error or undefined. Math error if you're using calculator. So by inspection, we know that the negative I in the Argand diagram is located here. Okay, that's the negative I. This is the positive I. So what would be our angle? Okay, if we have this, so if we measure this clockwise from the positive x, we have a negative angle. And this angle is negative pi over 2, okay, which is negative 90. So by inspection, we have an angle of negative pi over 2. Okay, so our polar form for this negative I should be r, okay, or 1 cosine of negative pi over 2 plus r, which is 1. So I'm not gonna write that. So we have I sine of negative pi over 2. So this is the polar form of our, this should be our polar form for the negative I. So in circuits, it's actually represented as this value. So we have 1, I think, angle, okay, 1 angle negative pi over 2. Okay. In your calculator, you can also do that. Okay. But for now, we are doing it for the complete computation. So number 6, for number 6, okay, number 6 we have, I think it's number 6. It's number 6. We have negative 4 square root of 2 minus 4 square root of 2i. It's easy, okay, because it's already simplified. We don't have any denominators. So our R should be negative 4 square root of 2 squared plus negative 4 square root of 2. We have squared. So the value of R should be 8. Our theta should be arctan of simply 1 because it's really the same. Okay? So we have arctan of 1. So our calculator will give us pi over 4. We know that this is located in the quadrant 3, third quadrant, because it is negative and negative. So we need to subtract pi from it to get the correct angle. So we have negative 3 pi over 4. So therefore, our answer for getting the polar of this polar coordinates or polar form, let me just rewrite this here. It's much spacious. So we have 8 cosine of negative 3 pi over 4 plus we have I sine, or sorry, we have 8i sine of negative 3 pi over 4. We can factor out 8, so we have 8 cosine of negative 3 pi over 4 plus I sine of negative 3 pi over 4. So that is our answer. Oops. So this should be our answer for this problem, number 6. Okay, so let's now proceed to number 7. For number 7, we have negative square root of 3 minus I. This is pretty straightforward. So we can apply the formula. So negative square root of 3, oops, we have negative square root of 3 squared plus negative 1 squared. So if we evaluate this, this should be 2. Our theta would be arctan of negative 1 over negative square root of 3. So as you can see, if we apply it directly to our calculator, it would become 1 over square root of 3. And since this is in the third quadrant, okay, quadrant 3, we need to subtract pi. So if we evaluate arctan of 1 over square root, okay, of 3, that is pi over 6. So we need to, again, subtract pi, okay, if it is, because we are using calculator, subtract pi from it, okay, and to get the real, okay, angle or argument. So our answer in getting the polar form of this should be r cosine of theta, that's 5 pi, negative 5 pi over 6 plus 2i sine theta, negative 5 pi over 6. Or we can factor out 2. So we have cosine of negative 5 pi over 6 plus I sine of negative 5 pi over 6. So this should be our answer for this problem. So let's go now to our last problem. Okay, maybe for problem number 8. So get or transform this into polar form, this complex number. So we need to simplify this first by multiplying it by its conjugate, square root of 3 plus I. So what will happen is this would be square root of 3 plus I. Square root of 3 times square root of 3, that's 3. Negative times positive, that's minus. We have negative I plus I squared, or multiplied by I squared. That should be negative 1. I squared is negative 1. Okay? So we have square root of 3 plus I all over 3 plus 1, that's 4. So let me just rewrite this. Square root of 3 plus I all over 4. So in other words, that is square root of 3 over 4 plus 1/4 of I. So it's pretty straightforward. forward here that we can get readily the r and the theta. So we have for the r, that's square root of 3 over 4 squared plus 1/4 squared. And take the square root of that. So it turns out to be 1/2. And theta for arctan, that's y over x, 1/4 over square root of 3 over 4. These two will cancel. Our calculator will give us pi over 6. But take note, again, okay? Take note that in this problem, we need not to subtract or add pi over 6 because the given complex number is given or located in quadrant 1. So whatever the calculator gives us, okay, that is the value of theta. So we have now, okay, to write the polar form, square root of 3 over 4 plus 1/4 I, the polar form of that is r cosine theta. So we have r cosine of theta, that's pi over 6, okay, plus r I sine of theta, that's pi over 6. We can factor out 1/2. So we have cosine of pi over 6 plus I sine of pi over 6. So this should be our answer for this problem. Okay, and let me just give you, okay, a problem that you can work on. Let me just see my examples. Okay. So this is your take-home problem. Take-home problem. Very similar to what we did here. So find the polar form of this. Negative 1 over negative 2 minus 2i. So this one. Okay? And the answer, so that you can check if you are correct, your r should be square root of 2 over 4. And your theta should be equal to negative pi over 4. Okay? So, and that's it. If you're new to my channel, please don't forget to subscribe, and I hope you learned something for today's video all about a polar form of a complex number part 2. So, thank you so much. Again, this is Engineer Abat. God bless you.